Welcome to my projectbazaar.com.
Now we discuss about the product for design and simulation of power efficient traffic light controller. Next we see the abstract for the product. Traffic light, which may also be known as spotlights, traffic lamps, traffic signals, stoplights and robots are signaling device positioned at road intersections, pedestrians crossings and the other location. To control the flowing of traffic, a signal controlled junction vehicular traffic is permitted to flow in a strictly controlled manner. The traffic flow, available road space, layout and stages sequence will all affect delay. The successful installation will impose a minimum delay on all traffic concerned with safety. In electronic system, when a production of a custom IC become expensive due to a small quantity, FPGA are extensively used to verification of conceptual design. Due to the high cost of building a mass production of a custom VLSI, especially for small quantity, system designs are now implemented in field programmable gate array. This paper presents design and simulation of power efficient traffic light controller. This main focus is on simulation and optimization of power efficient traffic light controller design and computing its speed of operation. In the conventional system, power consumption is high and the expensive. So we designed the power efficient traffic light controller is better than conventional in terms of lookup tables, complexity, size and cost. In this research, power of novel power efficient traffic light controller is presented with minimum number of LEDs, which fairly improve its performance and make the design efficient in terms of power and speed with respect to conventional design. The conventional traffic light controller has been implemented using the microcontroller and FPGAs. The research paper by the traffic light controller, which uses the sensor to maintain the continuous traffic flow, hence the power consumption is too high, which can be reduced in the our design of PTLC. The novel design of PTLC is an in the economical and possesses the characteristic high integration, low power and flexibility. The PTLC has been implemented on FPGA based process. The FPGA has many advantages: the speed and number of input and output ports and performance. This system has been successfully tested and implemented the hardware using and two designs for hardware description language based on VHDL code. Next we see the flow diagram for the product for power efficient traffic light controller. First, the traffic light controller mainly source for clock and reset functions. These are the source for power efficient traffic light controller architecture. This clock and reset function to set the activation and deactivation for overall traffic light controller architecture. The clock to activate the power traffic light controller architecture and the reset to reset the all values for traffic light controlling process. The activation process mainly to activate the counting architecture results. Based on the counting results, if the change the stating position for based on the counting performance and counter level. The state position to be changed based on our allocation of four side roadway traffic light process. This the present state and the previous state passing based on our overall FSM logic functions. These finite state machine condition process mainly based on present and previous state function due to the our clock and reset function results. This activation based on our counting architecture. These counting results to apply the stating position and the stating position to check the present and previous state and to display the results for output LED functions. These are the overall flow for power efficient traffic light controller architecture. These function to be modified based on the present and previous state function and to reduce the circuit complexity and to improve the power consumption level compared to the existing methodology. These are the mainly focused by an area efficient and to reduce the power efficiency also. This is our flow diagram for power efficient traffic light controller architecture design using the VHDL code. And finally we see the output for the product. First we run the traffic light controller ISC project. Our traffic light controller architecture was developed in VHDL language and to use the behavioral modeling process for to design our overall architecture process. Then to select the simulation and to select the traffic light controller code, then to run the simulate behavioral model. Then to create the iSim project navigator. This project navigator mainly used to simulate the our process. Then to apply the clock and reset function for overall architecture. Then reset condition to all output for set 0. Then to deactivate the reset and to apply the clocking functions. Then to change the our position for red and green and yellow position for overall 4-way traffic light controller architecture. Then to apply the clocking and to count the counting result and to changing the required state position due to the our counting result. These results based on our overall functions to change the overall architecture results for based on our LED functions using the traffic light controller architecture and to select the implementation process. Then to see the view RTL process. This add and create formatting. This RTL diagram mainly used to what are the logical blocks based in our RTL diagram, register transfer level diagrammatic representation. Then go to the view technology diagram. This technology diagram mainly used to what are the lookup table functions and input output. Then buffer position in overall IC function. Then go to the design summary process. This design summary process mainly used to select the synthesis report for overall architecture result. This report for device utilization function and the processing time, delay time for overall architecture results. This is the processing time and the processing frequency for speed. Then calculate the latency level for traffic light controller architecture. This is our device utilization process or overall architecture. Then count for slices and lookup table, then flip-flop pairs, then the bounded input-output function for overall architecture. This is our overall result for power efficient traffic light controller architecture results for device utilization results and timing summary results for synthesis report result in our traffic light controller architecture. This is the memory usage for overall architecture and the clocking time for power efficient traffic light controller architecture result.